Hello everyone, let's take a look at LeetCode 560, Subarray sum equals k. Okay, it's a very popular problem, and there are many similar problems like this problem, and it's also appearing in many interviews, for example, Facebook interviews. Okay, this is problem. Given an array of integers, nonce, and an integer k, we need to return the total number of continuous subarrays whose sum equals to k. In first example, we know first two one can combine the subarray whose sum is 2, or the last two one can combine the subarray. And in second example, the first two numbers, the sum is k, or the last number is sum is k. So the answer is also 2. Okay, let's take a look at this example, and assuming k is 7. Imagine that we just iterate each element and we keep a sum. So when we are at 1, we know the current sum is 10. So we want to find, is there a subarray, ending with this element 1, whose sum is k? We know the naive solution is we just for loop each element. So it can be like O(n) square. Or if we fix the last index, or the last element at 1, it will take O(n), since we need to for loop each element previously and to check if the sum is k. But there is a faster solution O(1) to check this. We know the current sum is 10 and k is 7. So we want to find the target. Target is sum minus k, which is 3. So if we have a perfect sum, whose perfect sum is 3, current sum is 10, then we know the elements between them are 3, like the sum of the elements are 7, right? So sum is 10, we know the prefix of this element is 3. So the elements between is 7. So we just want to store a perfect sum. It's like the two-sum problem in LeetCode 1. So we need to have a map to store the perfect sum. The key is the perfect sum, the value is the count. So let's go through this example. At first, sum is 0, answer is 0. And we're at element 3, so sum is 3. And we want to find target, which is -4. It's not in the map, so we didn't find 1. Then we put the perfect sum in our map, which is 3, and the count is 1. Next, we're at element 2, sum is 5. So we try to find -2. It's not in our map. Sum is 5, so we update our map. Next, we're at element 4, sum is 9. So target is 2. 2 is not in our map. Then we need to update prefix sum. Okay, next, we're at element 1, and sum is 10. Note, at this time, target is 3, and we track our map. We have 3, and count is 1. So we update our answer from 0 to 1, and store the sum in our prefix map. Next, sum is 18. Target is 11. It's not in our map. We update it. Next, sum is 12. Then 22, and target is 15, and it's not in our map. Then we update our prefix sum map. So this is a simple solution here. We keep a map, and we initialize sum and answer to 0. Then we just for loop each element. We update the sum, and we calculate the target, and we look up the target in our prefix sum, and add the value to our answer. At last, we update our prefix sum. But there's some problems with this implementation. For example, if k is 3, when we run this code, we will return 0. But we know that 3, the answer should be 1 since the first element is 3, so we do have 1. When sum is 3, k is 3, we know we need to find target 0. But in our map, 0 is not in our map. Where does the problem come from? It's because So the subarray includes the first element. So we need to explicitly update the map. If key is 0, then count shall be 1. In this case, we know when sum is 3, target is 0, then we know the count is 1, so we can add 1 to our answer correctly. Okay, that's it. See you next time.